have go. Okay, so this is question 10 from the summer 2008 Core 1 paper. Pulling together all of that stuff on quadratics. And it starts with something that we're familiar with. Now this is slightly harder than the example that we've just done. This is about as bad as completing the square is going to get. Completing the square isn't going to get an awful lot worse than this. There we go. We've got to write that in the form p brackets x plus q all squared plus r. You may have another way that you do this, but I'm going to do it with the comparing coefficients, really systematic way, where we're not going to make any mistakes. So we have p in front of the bracket. If we were to multiply out x plus q all squared, and if you want to do a little sketch of your kind of lines all over the place to multiply it out on the sidey paper, that's fine. It would look like that. You would get x squared plus 2qx plus q squared. We're not quite finished because we've not got rid of the brackets. We've got the p in front of it. So we're now going to multiply through again by p. Px squared plus 2pqx plus pq squared plus r. Okay. Now we've got rid of the brackets. We're completely in the same form on both sides. And now we do this thing where we compare coefficients. We have genuinely got three things to look at here, because let's start by looking at the x squared term. They've got to be saying the same thing on both sides of the equation. We look at the x squared. On the right we've got px squared. On the left we've got 2x squared. So straight away we've got that p has to be equal to 2. Great start. All right. So that was the blue bit. Now if we look at the x term, we've got a minus 6x over there, and we've got a plus 2pqx over here. So if we look at the x's, we've got 2pq equals negative 6. Except we already have the great advantage of knowing that p is 2. So 2 times q is minus 6. So q is minus 1.5. Minus 6 over 4 would be minus 3 over 2. I will write it in that form. I did say this is a tricky one because we've got these fractions coming into it, and that's a little bit mean. Now we've got to look at what's left. The common trap here is that people forget about the pq squared term and just concentrate on the r. The bit that's left is the whole of that. So the green bit is going to tell us that pq squared plus r equals 11. Okay. And again, this is tough. This is the last question on the paper, so this is supposed to be separating people out now. We've got to be really careful how we deal with this. This is p, so it's 2, and it's only the q that's squared. Now if you square minus 3 over 2, you would get a plus to start with. If we square negative number, we get a positive. We would get 9 over 4 out of that. Plus r is 11. Okay. 2 lots of 9 over 4 is 9 over 2. 18 over 4, 9 over 2. So r is 11 minus 9 over 2. And well, let's keep it as a top-heavy fraction. That's going to be what, 13 over 2. 22 over 2, take away 9 over 2. So that's our value for r. And the question said, express it in the form. So 2x squared minus 6x plus 11 expressed in that form, we had p, which was 2, times x plus q, and q was minus 3 over 2, plus r, that's squared, plus r, which was 13 over 2, and that is our form. And I think that is a really tough thing to have arrived at by any means other than doing that. You know, if you try and do the thing where you take out your x coefficient and half the x coefficient and square it and add that on and then subtract it again and tidy it all up, you're going to get tied in knots with that. That's quite a nice way of doing it. And that was quite a lot of marks. That was 4 marks for doing that. Now, the next bits follow on from what we just looked at. So it says, state the coordinates of the vertex of the curve. And we haven't mentioned this, but this is a really standard thing. The coordinates of the vertex of the curve, if you put it in complete square form, you can read it straight off that. You don't need to do anything else. And what we generally have is if we've written a times x minus b squared plus c, then the vertex is simply the point that the x value would make that 0. So its x has got to be b. And the y value is, if that's 0, it's whatever's left. So the y value is c. So in our case, in our question that we're doing here, looking at what we've got there, it's whatever x value makes the bracket 0. So 3 over 2. And the y value is whatever would be left hanging around if that bracket was 0. 13 over 2. That's it. And for doing no work, that's a really soft couple of marks. If you can just remember, completing the square always leads to that conclusion with the vertex. The vertex, of course, means the point, the turning point. The question then goes on to say, calculate the discriminant of this curve that we've got. I'm going to go on to a new slide for this. Discriminant of 2x squared minus 6x plus 11. We've just talked about this. The discriminant is b squared minus 4ac. And so it is going to be b squared minus 6. When you square it, you take away 4 times 2 times 11. We're just going to be really careful that we don't make any arithmetic slips in doing this. Minus 6 when we square it is 36. We're then subtracting, what are we subtracting? 4 times 2, so 8 times 11, 88. And so we're ending up with, what is that, minus 52? Okay, that was another 2 marks. And then the question says, state the number of real roots of the equation. Well, we've just talked about this, stating the number of real roots, that if this had been a positive number, that's 2 real roots. If this had been 0, that's 1 real and repeated root. If this is negative, there are no real roots. Is that a surprise to us? Well, actually, we had a quadratic equation with a positive coefficient of x squared, so that makes it a positive, a happy, U-shaped, smiley curve. The vertex of this happy, smiley curve was at plus 6.5. So the turning point was above the x-axis. If it's that way up, and its turning point is above the x-axis, down there, it's got no real roots, has it? It's never crossed the x-axis. So even if we hadn't done our discriminant stuff right, we should still have known there were no real roots because it can't cross the axis. And this question, we won't finish it off. We haven't talked about this stuff yet, but the final 5 marks of this one was find the coordinates of the points of intersection of the curve y equals 2x squared minus 6x plus 11 and 7x plus y is 14. Well, actually, this was a slight red herring in there because this didn't really require any of what we'd done earlier. You could have begun this question at this point without having done any of the completing the square or discriminant or talking about the curve. It's simultaneous equations. What we'd like to do with simultaneous equations is substitute an expression of one of the variables into the other equation. And they've set this up for you quite nicely. They've said that y equals this bit. We call these equation 1 and equation 2. Then we start y equals. So we may as well get that expression of y and substitute it straight into that one. So we're going to have a sandwich with this sub y in equation 2. There's a shop that sells sandwiches called Subway, so that was a joke, sub y. It was not funny and it's been caught on video as well. You could have laughed just out of sympathy, but we get 7x plus 2x squared minus 6x plus 11 equals 14. We've replaced the y in the second equation with what y was equal to in the first. I said just a few moments ago that, minus 3, sorry, that being able to factorize quadratics was a really big deal. And here we are, we've got to factorize a quadratic, and it just as we said, it's one of those ones where the coefficient of x squared is not equal to 1. Actually, this is quite a neat one because they're both prime numbers. So we could probably have a stab at just going straight into this. But because we've just done it, let's think about that special routine we've got for solving it. If we multiply first and last things together, we get minus 6x squared. Can we think of two things that times to give minus 6 and add to give plus 1? I think we probably can. Tell me two things that times to give minus 6 and add to give plus 1.
3 and minus 2.
3 and minus 2. Or minus 2 and 3. So let's rewrite it with those in there. That is 2x squared minus 2x plus 3x minus 3 is 0. We've got a common factor here of 2x. We've got a common factor here of 3. Oh, look, it's all worked out. We've got x minus 1 as our repeated bracket. We've got 2x plus 3. I know, faced with that quadratic, you probably could have gone straight into writing that out. I'd hope that many of you could, but this is playing it safe. We interpret this to say that we have 2 points of intersection when x is equal to 1 and when x is minus 3 over 2. And we're not quite finished because we really need to know the y value that goes with them. We've got a few choices. We can sub it back into that equation with dealing with the squared terms, but actually it feels to me like that's going to be easier to look at. 7x plus y is 14. So that would tell me that 7 plus y is 14, so y is 7. And the other one would tell me that 7 times minus 3 over 2 plus y is 14. I'm going to have to deal with some fractions here. That's minus 21 over 2 plus y is 14. If I add, well, how do we think this through? If I add 21 over 2 to 14, 14 is 28 over 2. So add another 21, that's 49 over 2. And that will do as my answer. Let's actually tidy this up slightly. We've got two coordinates, the point 1, 7 and the point minus 3 over 2 49 over 2, and that is our simultaneous equation solved. And if you want to, you can do that. There you go. Okay, does that make sense? And again, as long as you are careful and go through it step by step, that was 5 marks. That was a decent amount of this paper, and it wasn't terribly difficult. So it's all about picking up the marks where they are. Thanks very much.